Okay, this question is special request. I thought it'd just be easier to do it than to type in a response. Reasonably interesting question. I'm just going to do this. There's going to be no editing or anything, so if I make a mess, then I apologise. Right, here we go. There's some blurb here. We've got this thing spinning backwards and forwards like this, which is moving the potentiometer backwards and forwards. So when the potentiometer is in this position, you can read a minimum voltage. When it's in this position, you read a maximum voltage. So the voltage will vary. I suppose actually it will vary like this, won't it? Above some average value, which will be there. I'm going from a minimum to a maximum, like so. And the position, the voltage there that's varying, will be synonymous with the angular displacement theta there. Now if we think about the angular displacement theta there, and if that's the radius there, then for small angles the straight distance between there and there is r sine theta, but sine theta is approximately equal to theta for small angles, so you get r theta, which is the same as the arc length from there to there. So that's what's essentially happening, and your potentiometer is measuring the position of this bar here. Okay, so we got this rate here. We need to estimate the number of readings. So we got, first of all, we need to think about how much time we got. 1,000 readings, 100 readings every second is 10 seconds. So we've got 10 seconds of readings. So if we do 10 divided by 4.2 times by 5 means that we're going to get 11.9 readings, or 11 full oscillations. No, oscillations. Well, 11 full oscillations. There we go. What would the time interval between successive readings at this rate? So using 100 readings a second, we just do 1 divided by 100, so that's 0.01 seconds. Okay. This one here. Right. So, assuming, is that on the page yet? Assuming the ruler oscillated with simple harmonic motion, estimate the maximum displacement at the end of the ruler between successive readings. Well, the maximum displacement will be when it's travelling the fastest, which is when it's right in the middle, there. So it's swinging backwards and forwards like this. The readings are the same amount of time apart, so there'll be shorter distances between them on the ends, and it'll be the furthest distance when it's in the middle. So I'd write that down. The max displacement is when velocity is at a max, therefore in the middle. Okay, so we use Vmax is equal to omega A. Omega equals 2 pi f, and f is equal to frequency. So you've got number of oscillations 5 divided by seconds 4.2. So 5 divided by 4.2 is frequency. Okay, so we've worked out Vmax. So the displacement is equal to Vmax times by the time interval. So that's equal to 2 pi f a delta t, which is equal to 2 pi, f was 5 divided by 4.2, times by a is here, 50 millimeters, times by delta t, which was this here. Can you see that? Is that there? So that's 0.01 seconds. So we've got 2 pi times by 5 divided by 4.2 times by 50 times 10 to the minus 3 times by 0.01 gives us 3.7399 times 10 to the minus 3 meters, so 3.7 millimeters. Okay. Right, this one here, so just draw a proper circuit diagram. and we get R there. We got 4K7 resistor there. We've got 1.3 volts there. We've got, what's this voltage here? Is that 1? Yeah, it's 1. So it's got to go between 0 and 1 volts. So between here and here it's got to be 0 volts. To here it's 1 volt. Here is 1.3 volts, which means that the difference between there and there, that voltage there, has got to be 0.3 volts. Because then you've got 1 volt plus 0.3 volts gives you 1.3 volts. Various ways of doing this. You could use a potential divider equation with that resistor and that resistor there. I'm just going to use V equals IR, I think. So first of all, work out I. I is equal to V over R. We know this one here, so we know it's 1 volt over 4,700 ohms. And then we can just work out this. R is equal to V over I, which is equal to 0.3 volts divided by 1 over 4,700. It's equal to 0.3 times by 4,700, which is 4,700 times by 0.3, 1410 ohms. Right, there we go. So that's unedited, and I hope that was useful.